So if we look at performance, software delivery performance, so there's this really, really good report from Dora, the DevOps Research Assessment. So anyone who hasn't got that, you can link in with me. I'll send it to you. It's sponsored by Google. It's about 60 pages, but it's actually pretty good reading. And they talk about two things. They talk about throughput and stability. So throughput is the number of times you change your system, how often you deploy, and lead time for changes. So how long is something in the backlog? Again, on systems, 10 years ago that I was working on, the backlog got pretty big. Could be 3 months, 6 months, 9 months. And they also talk about stability, and there are two aspects of stability. So there's time to restore the service, which on my Barks platform was, you didn't restore it, it was going to take too long because people were trading on the system. And there's the change fail rate. It didn't fail that often. Actually, we were a pretty good team, and the system very rarely went down. But we were doing a trade-off. We were trading throughput for stability. And that is a problem, because stability always wins. In fact, you've probably all got teams that are solely devoted to stability, running the bank. They don't really want to, or running the business, they don't really want change. Change causes instability. So those are the two measurements that Dora look at. So again, coming back into financial services, so I think most teams are agile now, but they've got big backlogs. They're probably working on sprints, but the sprints need a lot of testing. So you might do 2 weekly sprints, but still do a monthly release. But it still needs a lot of manual testing. You may have unit tests, but it still needs a lot of testing to go out into production. And there's this disconnect between the business and developers, which is what I was talking about my story back in the early 90s, where the client is kind of disconnected from the person actually developing and releasing the software. But I think that's probably a fairly typical scenario for most people. So looking at the development process, so I think most people will be familiar with the terms continuous integration, continuous delivery, and continuous deployment. Now, there could be the start of a religious war over this slide. So this is one definition. So a lot of people are doing continuous integration. So you're maybe working on the trunk, or the developers are committing code into the trunk, and when you do a commit, the integration tests will run, and your code is kind of ready to be tested, normally manually after that. Then there's a group of people who are doing continuous delivery. And real continuous delivery, so real CI/CD, is that code that gets to be delivered could go into production at any time. So it's packaged, it's ready to deploy, and it could go into production at any time, a point of your choosing. But that is fully automated to that point. That's real CI/CD. And then the elite group, what are they doing? They're doing continuous deployment. So every committed change is going into production. So developers are committing changes, and that's going into production. That sounds terrifying and a complete recipe for disaster. And we'll find out, because we're about to do it, we're going to do a demo later, which is the mother of all demos that will go wrong, probably. Where we're going to do a change, and we're going to release it into production. Hopefully, you've all downloaded the phone app. If you haven't, there's a thing on your seat that shows you how you can get it onto your phone, and we'll do a continuous deployment demo shortly. But the elite group are doing continuous deployment. Now, I did see a few shaking heads and like, no, that's all wrong. But it's one definition. So what's stopping us? Why can't we just do this like all the other people outside of financial services? So our architecture, our tooling, and our metrics are stopping us. So our architecture typically is monolithic. It's very complex, and it's tightly coupled, not only within itself, but it's tightly coupled with other applications. And again, I haven't spotted the person, but I had a good, robust conversation a few weeks ago about, can you do continuous deployment on a monolith? And yes, you can. That is technically possible, but it's extremely hard in financial services because of the automation. But that's an inhibitor, our architecture. Our tooling, we have to raise change requests. We have to show testing evidence. We have to show what the actual change was. We have to show that we tested it in production. We have to show whether we rolled it back. We have to close down the change request. We have to show all of that evidence every time we do a release. If you're trying to release 50 times a day, that's just not going to work. So our tooling needs to improve. And our metrics, so when I talked earlier about the throughput and the stability as being two measures of a team, so the stability. So again, if you're doing a lot of releases into production, you have to be able to observe your system. You have to know that that release has either affected something or not affected something. So a lot of people have monitoring and alerting, the whole thing's gone down or it's up, or some high-level alerting. Lots of people have logging. But real observability on a complex system is actually quite tough to do. Although the good news is, obviously we're at Google and there's a lot of tooling available to do that. So talking about the architecture, just go into a bit more detail. And you'll be pleased to know that Henry from Google is going to go into a lot more detail on the technical side. But just to cover a broad level. So again, we could have a long argument over whether you need microservices for this. But we're going to show you containerized microservices, and we're going to show you Kubernetes and Istio. We'll talk about Istio as a technology shortly. And when Dora looked at the elite performing teams, they were twice as likely to have a containerized environment as anyone else. Infrastructure as code. So again, back to when I used to walk into the data center, effectively I was just changing the infrastructure myself. And we talked earlier about getting changes through the system and how complex that is with handoffs. Here you have to have infrastructure as code. So your infrastructure has to be versionable and you're able to change it through development. And what's really interesting is Dora found that the elite group were 23 times more likely to have infrastructure as code. 23 more times likely to be in the elite group if they did infrastructure as code. And again, we'll talk about that in a bit. And finally, PaaS, Platform as a Service, twice as likely to be in the elite group if you have a PaaS. So on infrastructure as code, we use Terraform in this example. And our PaaS is a GFT activator. So with the Google technology, we've built a kind of hello world type framework that includes the DevOps pipeline, the tooling, integration with change control, microservices architecture, and the ability to do that kind of release pipeline that I was talking about. So on the tooling, why do we need to make small changes? And why do we need to make them often? Well, in financial services, let's just talk about that, because of the change process. If you try and raise a major CR, when I used to do it, it was a minimum of a 2-week lead time, minimum. Code was finished, then you had to wait 2 weeks. So significant was longer. So what we want to try and do is get those changes down to trivial or insignificant changes, because that can then be automated. If my change is small enough, I can automate the CR process. I need to achieve that, I need to fully automate my pipeline all the way through. And I also need, as part of the journey, for people to be confident, the people that support systems and run the business, that they are on this journey as well, and they realize that multiple releases is still a stable system. And so by making small changes and automating that, you can take people along the journey. And then finally, the kind of release process that you want to do. So I'm only going to talk quickly about Canary release. If you want to talk about the others, then afterwards the GFT and Google people around that will explain the others. But a Canary release, for those that don't know, it came from the idea of taking a canary down to the mine to test whether the mine was safe, and if it died, then you'd leave. If it was okay, obviously you'd stay. So that's the point of a canary release. You're testing whether that release is safe. And so we will show you a canary release. And the idea is that you'll release a very small change to a very small number of people. And you can choose those people. You can have various strategies. In fact, depending on the service, you could have different strategies. So you could release to an internal group of users first, or you could release to a set of external users that agree to be a beta tester. So there's a lot of different ways that you can create that canary release, but it's really important in terms of getting the release frequency up. There are other release strategies. And then metrics. We said, there are 3 things: architecture, tooling, and metrics. So the 3 things we need to do with metrics, verify, monitor, and respond. So we need to be able to release that canary release and then run tests in production before we connect users to it. So we're doing post-release testing. And of course, some companies have taken that to, to great lengths of how they test once it's live. We then need to be able to monitor that. So once users started to be directed to the new version of the software, we need to monitor that. And we need to be able to respond if it goes wrong. We need to be able to roll back automatically. And again, key, I think, in financial services is that automatic rollback as part of the change request process. Otherwise, there'll be chaos.